is audience participation as well. You know, allow the judges to have their say, but we want everyone else here in the audience to also try to vocalize. And given your all's expertise in knowledge of the space industry and in business, we hope that you're there too. A couple of announcements. We are looking to change the date of round 2 to July 26th. Now, if that's okay with all the presenters that are here today, then that's what we'll do if you all are available. Yeah? Yes?
Good to go.
Good to go there. How about Ragnarok? You guys good on July 26th?
I am okay.
June 26th.
June 26th, thank you, yes. July. But we can always pull you in. Who else is Blaze? Oh, Blaze
Blaze is going to do remotely. Features in space.
Right.
He's going to do remotely.
Okay.
And I don't know if anyone didn't sign up on our sign up form, but if anyone else is pitching a space idea, you're welcome to follow up after everyone else. So.
Yeah, and save time because we're going to finish the line afterwards. So.
Yeah, we got lots of money.
A couple other announcements. Okay, so as far as events go in the NewSpace business, there is, let's see if I got these. So July 7th through 9th in Boston, there is the ISS R&D conference. And if you don't know, or if you think you may have an experiment or a product or something that you could test on ISS, they have a free workshop on July 6th. So it doesn't get you free to the conference, but the workshop is a one-day event in Boston if you're in that area. Then July 16th, this is why I was looking at July, because all these conferences are in July. July 16th and 18th is the NewSpace 2015 conference in San Jose. And we've got, the website there is newspace.spacefrontier.org. Actually, let me back up the website for the ISS conference. It's pretty simple, issconference.org. And then after that, there's the Space Tech and Investment Forum, September 30th through October 1st in San Francisco. That's an invite only, but you can request an invite. So go online there at spacetechforum.com. And then I know it's a little ways away, but I can't help myself, Steve. SpaceCom conference in Houston, which is November 17th through 19th. And again, really use the website there, spacecomexpo.com.
I just put down some flyers to that.
Great,
so,
good. Yeah, and if you have any questions, Steve, I'm sure I'll be happy to answer them. That's all the announcements that I have. I say let's get going.
Cool. Yeah. First up, we have Rocket Star with Chris Paddock and Mike.
No, I figured we'd save the slides for next time. Yeah. Kind of move around while I'm being photographed. So my name is Chris Paddock. I'm the founder of Rocket Star. And we're working on a rocket engine that will help the rocket industry create single stage to orbit reusable launch vehicles. Because today, every time you put up anything, whether it be a satellite, whether it be an experiment, or whether you're just trying to do transit, you have to throw your rocket away. So you're literally expending between $60 and $270 million every time you have to put something in orbit. So it's really the holy grail of things, which is why this is such a difficult thing to get done. But this is something that's pretty much been solved since the 60s and 70s. It just wasn't very viable until recently because of better materials, easier computer design, which can be quicker, compile better, easier manufacturing, cheaper manufacturing. We intend to use our contacts through NASA, through the University of Stony Brook, to cheaply manufacture some early designs, get some payloads launched in order to prove out the design and work on larger ones later. Currently, we're just finishing our CFD analysis. We plan to go prototype end of this year. I was actually on the Walt's facility today. I'm working with NASA and another organization to put up a demonstrator model either in September or early next year for a small venture class rocket. Where we're going to put it up to the carbon line, which is the edge of space, and deploy 2 CubeSats. We just tentatively signed our first client, which you can't really disclose, but they've ordered between 3 and 6 engines. Meeting with them next week. They're coming up to meet with me again. And there's various other machinations going currently towards our goal of providing aerospike engines to the rocket engine, which is an altitude compensating engine. So at the end of the day, we're looking to get seed money to finish our initial manufacturing. We have the team. The co-founder, one of the first managing members of NASA is on our board, as well as several different people in different areas of NASA, one of them including the one that's driving the Curiosity rover right now on Mars. We have a board member of the USO who also works with Sir Richard Branson, that's also on our advisory board and also an investor. So we're just trying to basically just smooth out the rough edges so we can start getting to manufacturing. And it looks like that's going to start very soon. So just real quick, yet again, RocketStar are building an aerospike engine, which is an altitude compensating engine to help rocket companies create single stage abortive reusable launch vehicles. Thank you. Yes.
So do you want to ask questions?
I actually prefer that the judges go first, and then you guys step in. No, it's okay. I have some questions.
So we know you a little bit. So we're working on a report that you were going to produce this summer. I think I was talking to Mike. I think it's out there. What was that?
Yeah, we're doing what's called computational fluid dynamic analysis. We're taking the base model of existing film mounts and engine and theoretical aerospike that we're designing and measure the 2 differences together, baseline testing. In addition to that, we're doing hypersonic flow analysis, because the big problem with aerospikes is you get to 30,000 feet, and everything after that is just a mystery because nobody's hot-fired an aerospike engine over that level. So we have a lot of experimental thesis that we're structuring through that. I'm actually meeting with them next week to see their progress report. They're actually extending a little bit because they had some other questions they want to analyze a little bit longer.
And that's a computer simulation?
Yes. I'm not sure if what supercomputers you're using, but they are using computers.
I have a question. In terms of this, like there's clearly impact on sustainability on the throw away the rocket every time that you launch. But I also I'm a little bit familiar with the concept in terms of how it uses water and it doesn't. You don't need to use the same type of fuel that you use in a regular rocket today. So can you give a little bit more background on the propeller?
The initial design we wanted to use was a byproduct of oil, which is called liquid oxygen, liquid hydrogen. So not only it's a green product, so it's sustainable. So you just basically let's break off water for electrolysis to make your fuel. But also when this goes to Mars, when this goes to asteroids, you can use in situ sources to fuel the return trip. So less fuel that you have to take there, easier to get back. But one of the issues is with liquid hydrogen, it's very reactive. It just destroys, makes brittle all things it touches. So in addition to that, we're also talking with a firm that is going to help us work with liquid ethylene and nitrous oxide, which is still much more green than kerosene is, and some other more green products that are more like methane, which again, methane is very easy to metabolize on Mars, everything's there, as well as some of the asteroids and the asteroid belt. So yes, I'd love to use liquid oxygen, liquid hydrogen because it just makes sense to me. But
there are different options and everything.
Yeah. It comes down to cost, reactivity, transport, all the fun stuff that it deals with. We really just want to get something out there that a minimum viable product works, and then we can start doing all the fun stuff.
Good question. So you said you already have one client signed up
Yes.
right now. How are you reaching out to these clients? Like you have a
Any way that I can. We've met people here. I've been to a lot of different trade shows. I've met this client actually at the lunar surface workshop. And, I don't think that gives anything away because there are a lot of people there. But yeah, I mean, we have our own connections through NASA, through Bob Pressman, who's the member that I mentioned earlier, one of the 11 founding members of NASA. Orland has a lot of high interest. Sits on board with, I think, Lockheed Martin, the CEO, I'm not sure. But that's for later, because we get set up. But the initial one it's very grassroots. One of the chief things is I'm not trying to target right away the larger block providers. Because a lot of them vertically integrated, including SpaceX. Even though I'm still talking, I'm not really talking. I'm more focusing on the medium to small payloads. Like a lot of the CubeSat providers, they really want something like this to get up there. That's why they're showing a reusable launcher next year. And there's not a lot of service for the smaller payload manufacturers because they really have to just get in line and get onto the larger rocket. I mean, SpaceX used to have the Falcon 1, and that was kind of addressing that. They kind of retired that because there wasn't enough clientele to justify having that go up every year. So you're talking about redoing it, but Firefly is now working on it. I'm talking with them to help them with their engine work, but they're in various different stages of this plan. I'm going to see them in August, so August.
So is your plan to get a contract, like get a contract and then build a launcher for them? Or is it like, what's the production plan?
We are building a launcher. We're bootstrapping. We're getting an SBIR from NASA. We're currently involved in the infrastructure of the Space Activity, Kennedy Space Center, Marshall, and Humber facility. We are talking with this client to build their engines for the separate launcher, and we're developing our own separate prototype for them new clients. In addition, we're also talking with Kennedy to license their existing aerospace technology manufacturing. So while we're still pursuing our more advanced version of the aerospace, we don't want to just take an existing aerospace, playing around with it a little bit, paying some license fees, and go straight to manufacturing.
So, aerospace engine is much more efficient. It's an altitude compensating engine that you're saying it delivers a single stage orbit launch essentially. And I know that SpaceX is also working on those problems without an aerospace engine. I'm wondering that if you are SpaceX, for example, or some other customer, like what does the cost savings look like with an aerospace engine versus a regular engine with good technology that can deliver that capability?
SpaceX is kind of a difficult thing for now. I've spoken to Elon already about it. He wants to see some videos of rocket again before we go further, which makes sense. But they are vertically integrated. But to answer your question directly, if they had an aerospace, they could use the thrust factor and bring down margins. Their cost would go down by a factor of 30 to 50. So you're talking, the first initial cost is going to be built, and then assuming they keep the rocket, keep using it, their cost of fuel costs a couple $100,000.
Well, my colleagues have been awfully kind to you. I'm not
Good.
First of all, you need to speak up.
Okay.
I'm sitting here in the back, and I noticed some other people who are sitting up here in the front are leaning forward.
Yeah.
Trying to hear you. So, especially in the last few minutes.
You stay like that's my problem.
You kind of drop off. The second thing is, you haven't told us about your team. Who is actually working on this? You told us who your advisors are and who some of the big guys are. But who do you have actually doing the work, and what are their qualifications?
It's a very good question. Caluso, who's not mentioned on the website, is a doctorate at Stony Brook that has, his background is hypersonic propulsion. He brought him in for that particular reason. Satirius Morales used to be the propulsion director for internal combustion for GM in Europe.
GM, did you say?
Yes.
Okay.
Anurag Purwar is kind of the lead engineer that's kind of like on the strings. He doesn't have a lot of space background, but his background is delivering and executing on engineering projects. He's done it for many different companies, including Raytheon. And the key about that team is I can expand or contract as I want for the university. It's a very robust team of engineers that I can tap into. Outside of that, I have advisors through the university and through NASA that can kind of like direct me, like, well, you need to do this, you need to do this, you need to do that. Like shape testing on a shot, or dealing with PSC and dealing with that. And part and parcel with that is whatever strategic lines we're going to get through Kennedy. Because it's not going to be, okay, here guys, here's the teams, use whatever you use. They're going to be telling us, well, why aren't you doing it this way, or why aren't you this way? A lot of that's going to pour into and mix around with what we're doing.
You mean for that space act agreement you're going to do with KSC, they're going to be telling you what to do?
No, but I'm sure they're not going to keep their mouth shut, that's for sure.
Yeah, but you want to have a foothold in there. You don't want to go in there and have them lay the groundwork for you. You also want to save your claim.
Yeah, but at the end of the day, they're the government. I don't know what you are.
But you can. I mean, they expect you to. I mean, push a little bit at any rate. So
Yeah, so
You
far.
got a competitive advantage, so you push.
Yeah, I'm the one bringing the money.
Yeah, exactly. And the product itself.
I haven't seen any need to push so far, but I plan to push back, and I have pushed back before on other entities when I need to. So, yeah.
yeah, with the space act agreements, it's just like I said, state your claim at least.
Okay.
Even if it's the size of a pen, you want to.
This is mine.
You want to hold that. The other thing that what I could not figure out until one of the questions came down here, I think when Ashel asked you about the marketing. So, I mean, the purpose of this engine, I could not understand until you answered that question. And as I understand it right now, it's both a satellite rocket and a launcher rocket. Is that correct?
It is an engine,
It's an engine. Okay. Well,
whatever you need to use it for.
Well, what do you think it needs to be used for? What is your purpose? I mean, what is your purpose in building this engine?
Reusability,
That's your purpose?
yes. Single stage order reusability, turning the rocket industry to the jet industry.
So with that effect, who are your customers?
Everybody in the rocket.
So when you say you're building an engine, is it just an engine, or are you going to integrate it to other rockets, or are you building the whole rocket?
Currently, we just want to do the engines, but I'm always keeping my mind open to new designs. I mean, I didn't expect to be making a venture class demonstrator rocket later this year until I met. And they're doing most of the launch body parameters, the timing, the nose cone, the fins, everything like that. I'm just building the engine, having this thing.
So it has applicability to both launchers as well as satellite rockets and any other versions of space vehicles.
Yeah, we got-
What's the market for rocket? Tell us about the market for rocket engines.
Launch vehicles currently have a $6 billion a year market cap. We plan to tap into that, hopefully at least 10%.
Are there any other companies that do just engines right now?
No.
And like
Aerojet.
Yeah, but there's, they're really kind of the whole package. They don't walk in and say, I just need an engine. They kind of do everything within UTX and work with it for the whole package.
So you're not going to do that?
Well,
Not initially, it's too, the overhead is just too much. I really just want to get something out first. And then, if it makes sense.
You gotta get the minimum viable product, like you were saying.
Yes.
Like that's your competitive advantage is not in like the housing of a rocket, it's in the engine. And so if you can build the best engine out there, then everybody who's building rockets will come to you and say, we want your engine in our rocket, whether that's a launcher or satellite rockets, and that's what's up.
so you can conform your rocket, because I know, Virgin Galactic has had a big problem with their rocket engine because they developed the vehicle first, and then they develop the rocket engine. And you're coming at this, I mean, hopefully, you'll be able to say, here's your rocket engine, guys, develop your vehicle around this. But are you going to be able to sell to customers who have the reverse, where they have the design of the vehicle, and maybe they need a rocket engine, they need to be able to put it in there?
That's what I'm talking to on Tuesday. They already have the aircraft in on the engine.
I'm sorry, could you say that again?
That's what I'm talking to on Tuesday. They already have their aircraft in on the engine.
And that's your customer that you can't mention.
Yes.
So you have to prove to your clients this is the best engine available right now. What do you think, what are the steps you need to take to prove your credibility in the market, that this is the engine to go forward with?
Luckily, we've got a client that I can't mention who is going to help us showcase it. So it's not going to be a quiet sort of demonstration. They're going to put it up, and they're going to put it across the country.
That's the CubeSat launch?
No, that's separate from CubeSat launch.
Are you doing any test launches before you did the CubeSat launch?
I want to, but from what my partner tells me, it is never we won't need to.
Any burn tests on the ground?
Absolutely.
How many tests?
I want to do at least 3 to 5.
And you said yourself, so the industry is very vertically integrated, and traditionally all these companies, they just design their own stuff. So you see that as a challenge of getting your rockets into all these?
That's why, in addition to building the engine, you want to create the expertise around building the engine, so we can sell our expertise and consulting. So we become more of the standard for hypersonic tracking. Where you may have your own stuff, and you want to call it your own stuff, we'll just come in and help you see things on differently, share our experience with you, data for God.
Yeah, it's probably the first, it'll be the first time it's happened in the industry, so.
So this is, do you, right now you said that there are 2 areas of the business, one of which is the regular aerospike technology, which you mentioned you're licensing to somebody.
No, we're developing our own, yes, we're developing our own aerospike, an updated one, but we are talking with NASA to license their existing aerospike tech, whatever they have. They have like 400 different patents.
So do you have patents of your own?
Not yet, no.
Okay. When you apply for the, what do you know what the timetable looks like for that, like once you have something?
I would say 18 months is probably.
Okay, all right. Got it. So would licensing your technology be in the business plan in 2 to 4 years?
That's up for debate. I'm open to it, but I'm not sure if that would compromise our business model.
Okay. Go ahead.
It's just more about like getting to know the customer. When you go and try to sell the technology or the engine to your customers, what do you perceive is the biggest pushback you might get?
Who are you and why should I buy from you?
Okay. And how do you how are you gonna answer that question?
You know, it's different for every potential sale, but that's why I have super credibility of my team. You're not looking at me, whatever credibility I have. I have a founding member of NASA. I have this guy, I have this guy, I have a hypersonic welcome. All in the whole time. Obviously, a little bit smoother with my
So I'm a little bit skeptical about the question why this hasn't been done by NASA, because this has been on their back burner for a while. And then there's a company that was contracting with them for a long time, that was doing aerospike back in the 80s and 90s, is that right?
Yeah.
So really this engine, if it delivers what it's supposed to, is a huge cost saver. And from the side of things, you guys are like looking for something in the range of like $100,000 to $200,000 for R&D. Maybe that number is
it keeps contracting and expanding.
and that changes, but it's on that order of magnitude. Yeah. Right? You compare that to NASA's budget during those time periods. Why has this been on NASA's back burner? You really have more dollars to be able to to develop this.
They have more dollars, but they have more overhead. They have more. If you ever dealt with the government, I'm sure a lot of you have. It's just such a quagmire of roadblocks that should not exist. We're small, we're fast, we're driven. And that's how you get things done. And that's one of the reasons why NASA had to finish this. They had it working back with the X-33. but they just canned that because they figured out, oh, my tanks aren't what they should be. They went back to locking them back in assets. Like, yeah, we need another $200 million to fix it. It's like, no, you already spent $1 billion of our dollars. I think we're done. So there's that much of not just governmental, political issues dealing with this whole massive project. We distilled it down to what needs to be done, what can be done, what will be done. We can be done a lot faster, cheaper, fewer access to the university and other industry contracts than an asset can. And they would prefer that because they're cash strapped as it is, believe it or not. They'd rather be doing experiments than working on, new operations.
Tom Shaw asked what was the biggest struggles for your customers, but I think the biggest struggle is going to be engineering your product, your engine design. So do you have any ideas of how much that's going to cost your customers to integrate your engine into their product?
Ideally, they're going to have their own systems integration. We can just make them. We have investigated that. We have other companies that we're working with that will work on an hourly rate to help systems integrations. I don't feel it's going to be cost prohibitive. I don't think it's going to be more than 10-15% of cost.
Have you considered insourcing the system integration inside the company?
Yes, but I have to get full capital.
What stage are you in your engine production, and how long will it take to get to first hot fire?
Yeah, probably we'll have a prototype done by the end of the year. Right around then, it's cold fire, hot fire. I was telling my friend, we want to do they want to launch the CubeSat launcher in September of this year. Sounds great, but probably looking at April next year. At the earliest.
For them? Or
For the venture fire project. And that's just getting everybody together, getting it done, especially with some. The client will probably have them these burn testing their aircraft with back in maybe November, October, then not piloted, and then piloted flights eventually.
So what's your production time? So presuming you're going to do the first engine, your prototype, and all goes well with the prototype, and it gets finished at the end of the year, you get hot fire. And then presuming after that, things are perfect and you can go into production mode. How long is that production time?
I'll say 3 to 6 months, but I know every industry gets started lumpy, so it's probably going to be longer than that. Just dealing with new personnel, dealing with management, dealing with logistics, dealing with sourcing supplies, all of that, getting a certain rhythm before you start getting really tight.
I recommend that you do a project management plan. Just to even just give yourself a ballpark and put in some of those things, but that's going to be a question that the investors are going to want to know. Because if you're sitting here and you're telling me that you're going to be selling 6 to 9 engines to a prospective customer, how soon, how quickly we will do that? That's revenue in your bank. So
There's a lot of variables involved in it. There's a lot of things that are in motion right now that achieve that figure shortly.
Understand, but that's where, and
But
that's where, yeah, that's where you
very
need
much
to,
right, yeah.
yeah, that's where you need to do all of the parameters and lay it out. And so, it's a systems or a component, it could take you 2 weeks, it could take you 2 months, but you at least have to have that in your head. Especially when something like this complicated as a rocket engine.
One of the things that you mentioned before is that nobody knows what happens to an aerospace engine above 30,000 feet. And if I were a setting CubeSat that I designed and built up in that rocket, or if I were doing $150,000 capital, do you have contingencies for that rocket explode? What does that process look like?
Talk to the insurance provider there. They've
volunteer to help us out with that, basically the pilot. Let that cost them again. Well, no, built accessible.
Right.
Outside of that, we're not just doing outdoor testing, burn testing around. We're probably going to go to one of our communities where vacuum chamber to simulate without the open conditions where it's vacuum space.
And you have like the monitoring, so like, let's say that happened, we should out to like, would you be able to identify what happened the same way that any other test?
All of the contingencies and everything that they have an actually plug into, telemetry, the SPN system, where we can map everything out so that we can all that data. And just footnote to that, even if we get up to 90,000 feet and it explodes, that's still new data that we can then sell.
But you don't want to do that for a customer.
Right, that's why we're asking you to donate those UTEs.
Oh, you did a good job, Chris. Now we're going to hand you over to.
Okay.
You guys got any questions?
I think you have one first, right?
Sorry. What sort of specific impulse do you shoot for with this engine?
It's all over the map, but we're if I remember correctly, it's over the 400 level. But I'll have a clear picture of that happens to begin this week, and they get finished with the receiving.
Is it upper stage engine? Did you say it's an upper stage engine? Did you say?
No, single stage. So, yeah.
Single, so once.
Yeah,
So 400 seconds on this speed.
that's the goal. Yeah. Yes.
So I'm trying to understand SSTO aerospike. Vertical, air launch, how does this work?
The way we're doing it now with our demonstrator, but it's not to say that we're always going to do it this way. It's going to be vertical to drop off before it hits the ground and fall to the water. Ideally, it would be vertical to glide. But that'd be a whole story that would do with the avionics of the aircraft. I don't want to do that. I want to find the client who wants to do that. One of them we're going to talk to is Game Dynamics and let them worry about all of that complexity involved in the aircraft.
So you want to do an aerospike vertical?
That's
Vertical
one,
launch.
yes, vertical launch. The one that we're going to use a rail system that NASA has involved.
Sorry, you're using what?
The rail system at the Wall facility at NASA in Virginia.
Sorry, what's that?
They have an existing sounding rocket rail system where you can bolt on your own design rocket and just launch it.
So
Because he's waiting.
Okay, in this whole thing, we've heard a lot about technology, which is fine. We won't really know how well it works until you actually put it off and you hope it works and it doesn't suck. What I have not heard yet in this presentation is anything about the value proposition. Right now, what I see, what I'm hearing, is that build it and they will come is kind of a really good business model. Now, in 20 years of looking at these kinds of companies, there's a trail of wreckage miles long of companies that have tried that kind of business model and have failed miserably and wasted lots of investors' money. I don't want to see investors' money wasted. I've been an investor myself. And so one thing I did not hear from you was, how much money do you need now? What milestone do you expect to hit with it? How much more money are you going to need later? And I know you're going to need a lot more later. Okay. And what's the value proposition for investors, and how long they're going to have to wait for a return, and what do you base that return on? How many, I say you don't know who you're going to sell to yet. Okay, fine. How many do you need to sell to before you break even? How many more do you need to sell to before you start paying your investor back? These are the questions I have not heard answers to in all of this.
So first stage, we're looking for $250,000 to get us through the prototype, hopefully one flight. Next is the seed round, probably about $1.5 million to get people in, get some, either we're doing subcontractors or we're doing it in-house.
What's the time frame? So you got your $250,000 to do this to when? A year, 18 months, you go for the next.
I'll say 18 months, but
Okay.
much less, that's probably like 9 months of this.
Okay.
We're already like halfway through that.
Because we started talking about this earlier in the year, now we still went, even though nobody gave us money in bootstrap.
You're gonna need another one, I know, it's because the rocket science ain't cheap, so you're so far.
Sure it is.
This is small change, but, please.
So $1.5 million business started production.
Yeah.
And then it becomes, the 20 plus when it was like Series A and everything else like that. That's difficult for me to talk about because there's so many more things that come involved that I won't know an answer to until I get there.
Sure.
I'm not the one that's talking or will ever talk, build it, they will talk. I'm going out to get the guy, and then I'm going to build it. So, which is why you hear me talking about, I already have clients. I've been working all year to get clients, even though my prototype's still in development. I know for a fact that's how it works because I built a company before. I built it with, I have a great product, I have great people that will show up. It didn't. I had to pivot 1,700 times because I started a financial company during the 2008 crisis and figure something out. I don't want to do it. So, which is why I'm getting the client before I even want to get the money in. Ideally, I won't have to have investors because clients can deposit 30% while I get things done because we roll them through, even though I'm break even or running at a loss, financing coming through. The value proposition for investors is very difficult for me to tell you right now because it's just so exponential with the things. But we're looking at between a 20 to 30% profit margin now. Hopefully, we'll be able to make that bigger in a year or two.
And that's based on how many sales?
You
You sell how many engines to get a 30% margin?
Well, the
You're selling engines.
The 6 engines I'm talking about.
Okay.
And the other engines that I'm talking about. One thing I didn't mention is a launch provider that I'm talking to that wants to partner up because they have a customer that wants to do 12 flights a year, minimum $10 million a year. Business from the client, which would be more of a 35% So we want to get investors out between 3 to 5 years. So that's kind of your turnaround point for people who are coming in at this early stage. I don't want to be operating not at a profit for 3 years. I want to be at a profit as quickly as possible. Hopefully I'll be doing it this year. I know what it's like to not run a profit for a very long time. Forget about some investors, which I hate doing for investors. I don't like going through because I can't pay myself. I'm starving. I need to feed myself. So I want that profit coming as soon as possible.
So if you can get an aerospike vertical to 30K feet, what happens for the next
327,000.
327K?
Yeah, carbon 62 miles.
Okay. Then what happens for the next 100 miles?
We have on Esper range some converted ICBM engines that are sitting in Sheboygan right now, which would then push up the deep satellites across the coast.
So you're going to use like a Minotaur kind of model?
Me. And we're designing it now, so we're not really sure.
So why wouldn't I just go with a Pegasus or a Taurus or a Minotaur?
Because orbital charges a few hundred million.
Okay.
Ideally, this is going to be a cheaper, faster, better product. And then later on, with the value proposition, service involved in customer appreciation that's different from
So what are the limits of your, how high and how fast is an aerospike work?
Technically speaking, you can go as high as you want. You can go all the way to Mars if you have to. Technically speaking, you can go all the way up through the lower orbit and beyond. And you can go all the way to Mars with that engine if you want. Not very efficient, but you could do it.
So, and aerospike would go to Rio?
Yes.
I just have some feedback to which that you made. Like you definitely are very well versed in all the science and the technology behind it. But as a person, for me, like for example, who doesn't know the technology that much, I was more looking for like what's the customers, what are the exact customers you are targeting? What is the market size that you are approaching? As we mentioned, the value proposition, the profit margins you're looking at. So in that 10 minutes, like for an investor who doesn't have the technical background, if you can put some concrete numbers to show that yes, you have really studied the market and you know the customers and you know that now this is when I'm breaking even and this is what I need to know, these are the engines I need to know get to break even profit margin. I think that's going to make it richer value.
I'm cursing myself right now because I have no slides.
I'm sure you do, yeah, we're just adding that.
No, you're absolutely right. Thank you for criticism.
And yeah, I would agree. I mean, work on the differentiation. You know, what makes you better or different than Orville? I mean, it's the fact that you're cheaper, better, faster should not come at the very end of your talk. So work on the plan. I mean, exactly. What are put yourself in the investor position. You're going to give yourself money. Exactly what this gentleman in the blue shirt was talking about. What are your milestones?
That's great.
What are your milestones? What are your budgets? And then on the marketing. I mean, you have to step away from the technology and think of it in terms of a business product. And it's great. Technology is fine. Sure, it can be one of these things that changes the industry. But no investor could even care about that if they're not going to make their money back.
Yeah, and I think one of the really interesting things is that you quoted a $6 billion, right?
Yes.
Size market for launch vehicles.
Yes.
Right now. That's basically driven by everybody who can afford to launch at the costs that they're on today.
Assuming no growth, that's what it is now.
Right. So you're actually expanding the market by servicing this pent-up demand for people who want to get stuff into orbit cheaper. You're tapping this this part of the market that doesn't necessarily exist. Are you also thinking that you're going to be, you think you're going to be slicing off a chunk of the existing market?
I'm getting involved in this not for what's today, I'm getting involved in what's tomorrow, but as a business owner, I'm concerned about what's today, how's it going to pay my bills? So that's why I focus on the market today. You're absolutely right. Someone told me, I think it was Rob told me, late last year, 4,000 different satellite companies registered for the FAA to fly 4,000 different satellites. And the year prior, it was like 15. So it's a massively exploding market now. Just in huge sets alone, and small sets alone. And that they're going to need a bus to get them up there. I mean, right now, Nanoracks is back up like 2 years. Which is great for them because they have guaranteed product in 2 years. It's great for business. But it'd be great if they were just servicing, launching every other day. You can't do that right now. Even with this engine, you will not be able to fly every day. You'll still have to ramp up their facilities, ramp up their flight capabilities so they come down, refill, go back up. It sounds simple, but it's a lot involved.
See, that's one of the things that I think is really interesting, this idea of expanding the market, and all of a sudden you go from, you did say 15, 4,000?
Yes.
That's gigantic.
Yes.
Gigantic.
Again, that's the slide I don't have.
To me, that is what NewSpace is about, rather than the existing launch market, which is, heavily government involved, and, you've got the aerospace complex that already exists, bringing these new players into, and servicing that market.
Yes.
To me, what most people.
All right, last question.
The word visibility is kind of a loaded term in space flight. We all remember the space shuttle was reusable. We only got 10,000 people there for 6 months, check each of the thousands of re-entry tiles, do radiograms of the main engines, et cetera, et cetera, et cetera. What kind of costs do you foresee in terms of refurbishing this engine to prepare it for the next mission? What kind of lead times do you see?
With materials we're planning to use, we don't see that much of a downtime, but it's still a factor that we're going to analyze with our subsequent burn tests. And after a couple of real world flight tests, we can hypothesize all we want until we put bird up there, it's not going to matter. So we don't see it as cost prohibitive for the ultimate client or time prohibitive. It's not like it's going to have to be on the ground for a couple of months. After it gets up.
Thank you, Chris.
Thank you.
Back to Rock Industries, and we'll get to your next.
I have it full, correct. Something.
My turn here. Oh, we can plug it here?
That's a great idea.
You have a VGA? Almost like that on your laptop.
Actually. I can use my laptop.
Yes. I went to grad school. Splash pad. Oh, because the back thing. It works. Like some security. Yes, so I'm just gonna grab
Don't forget more wine. Okay, it's still good. There we go.
No, we haven't. space car. But yeah, so we're talking about
Yeah, sorry to go on.
Okay, we're ready. I guess. Hello, everybody.
All right, we have your attention, please. It'll take 10 minutes and then 20 minutes for questions, right? And then to public, right? Okay, so my name is Luigi, and I'm here with Kyle. Pretty much, we are proposing something straight up off the bat, cislunar navigation service. And we will go and step into this and explain what this means. So, cislunar space is the new high ground. Now, what does that mean, right? Currently, you have GPS, and GPS available in this volume around the Earth at a certain altitude, right? Beyond that, though, there is a chance that you can capture GPS packets. However, you need a special GPS receiver. So the recent mission as of this year, and the beginning of this year, the first quarter, MMS. So this is a NASA science mission that's carrying a specially made GPS receiver that can actually capture the packets that are sent out via the side lobes. Now, this is one technical term that I'll just explain, and then we'll go through it. Side lobes are basically the pattern from your radio antenna that just occur naturally because they're waves. So this is what's sent out from the side, so they're much, much weaker. That's why you need a special piece of hardware to capture them, and then your service that you have, your GPS service, it really ends up being spotty, right? So that's where we step in, and we are basically proposing to fill this void to basically have minimum of 4 satellites in orbit, in this halo orbit at the Earth-Moon L1 point. So that's a halo orbit. So if you think of the world, right, the world has the moon, everything's a plane, like a nice table, and the sun. So these 3 bodies are on this table. The halo is at a 90-degree angle. So it's like having like a hoop hanging off your finger, right? Pretty much. So anyway, the purpose of this is basically go over and say that from this distance, it's possible to broadcast these packets. So from EML1, you can broadcast these packets towards the Earth, meaning that technically you can then capture them with a normal patch antenna, and then you can offer navigation services between where it cuts off all the way to the moon. So founders, so Kyle and myself, currently I'm studying X-ray navigation for spacecraft. Last summer I worked at NASA Goddard, and I was working on CubeSats. I was hired on as this government contractor, and that went on until January, right? Aside from that, I'm doing my own PhD here at Stevens, and I have 2 more years to go, and hopefully it's 2 more years, because that's always how it is, right? So it's 2 more years. And Kyle and I didn't actually know each other until we met in person there. We both happened to intern also at NASA Goddard.
So I'm also at Stevens, working on different PhD projects, and we were both at NASA Goddard last summer, working on different projects. So
just so you know, NASA Goddard is right outside of DC, and I just got back from there today. So I took a bus and a subway. I didn't even have dinner. So anyway.
yeah, so Luigi's work at Goddard last summer
was involved in making this CubeSat called Dellinger, which is
6U.
Yeah, 6U CubeSat. And so that one will fly later this year. And based on that experience, the two of us partnered because we want to compete in this CubeQuest challenge, which is a NASA-sponsored challenge with prizes on the order of millions of dollars. And so for that project, we are currently developing this. We have a very successful SRR. That's the development phase.
System requirements review.
Yes. So, and our delivery date is March 2017. So we have that project. That's kind of our background experience for our team.
Right.
So you're currently working on that?
Yes.
Yes, this is just a small aspect of this larger business model, and we'll basically jump into that soon. So we have this technical advisory board on this stuff. And of this board, it includes Greg Bauer, who worked on MMS, and these results will be published soon that you'll see that there's actually spotty coverage, but you can't capture GPS packets, right? Charles Flaggen with Mel Boss, Tom Clark is a GPS engineer, and we're happy to work with him. It's on our board. Also, has anyone ever heard of AMSAT? Does that ring any bells? Yes. So, I mean, you guys, if you know AMSAT, then you'll know these names, right? So, George Davis is part of Emergent, and they work on the special navigator receiver, right? And we have Nirav and Michael Tempola. So let's just go along.
Yeah, the point of this slide is that in order to do the technical development for this GPS, not GPS, but it's related, you're relying on these devices. So now I want to talk about what is the actual market that we can try and capture. And the idea is that so the satellites, they work in between GEO and the moon. So 20,000 to 380,000 kilometers. Anyone who passes within that range can make use of our service. And it's actually, this is important because let's say you're going to Mars. So when you're passing in cislunar orbit, you have these critical burns. And during those critical burns, if it's a high profile NASA mission, they'll actually pay for continuous usage of the DSpace network in order to give them their trajectory so that they can make the burns appropriately. But then beyond that, if you want to say a lot of people may think the moon, Apollo, we did the moon, we're done with that. Who's going to the moon now? Well, actually, lunar science is a very active field of research. And so there have been studies saying maybe there's no commercial prospects for mining the moon. Maybe there is if launch costs come down. But if you just look at a lot, this is the last 7 years, or 10 years, there's been a lot of launches towards the moon. And if you want to talk about future prospects, as Rocket Star was saying, look at how this is cube launches by year. And look at how it's exploding. And it's exploding not just, I guess you can't see this, but this red line is commercial launches. So commercial space in Earth orbit is exploding. However, commercial space beyond Earth orbit is not exploding yet. There's just a delay. So if you look at a Lunar X Prize is going up soon, CubeQuest Challenge is going up soon. The technology is becoming cheaper that launches to cislunar space is going to happen. And every single one of those can take advantage of our system. So you want to talk about competitors. We have Deep Space Network is the main competitor. That's incredibly expensive, it turns out. High-profile mission spends millions of dollars to DSN over the lifetime of the mission. And these other things, Near Earth Network, is actually not really applicable beyond LEO. But there's a private corporation, Universal Space Network, and there are people using private ground stations, such as AMSAT Deutschland has a very nice 20-meter dish in Germany that they like to use. That's just, yeah. Dishes. So those are just some examples.
Okay, so basically our own revenue model is based on having a monthly subscription or an annual subscription. Basically, this is at the same exact method as ESA's Galileo. Right now, they're offering free public GPS. This is a project that's already operational. And now you're thinking, wow, why does that even matter, right? The thing is, you would pay a higher amount to have better positioning. And that's important if you have, let's say, some agriculture, mining, and whatnot, right? So we want to follow the same kind of model, and we would have this type of approach where people would basically pay us what they would pay BSN and have a better service. In fact, you would have constant tracking, not just basically the type of tracking that you have to schedule 3 hours every 2 days. You have constant tracking, which is amazing. And also so that you realize if we can offer GPS from that point, it's a one-way thing. If you're tracking from Earth, it's two-way. You have to send a signal out, let it come back, and see what the drift is, and then you know you have some kind of ranging idea, right? So we're looking at these past missions that have gone to the moon, and these are not only from this country, America. I mean, we're looking at other countries as well. And like you have like the entire Chang program, you have the Chandrayaan program, and there are some flights that have been from Japan, right? Pretty much everyone is stuck paying BSN. So you initially think that what's holding us back, trying to get to the moon and beyond in terms of like commercialization, you're looking at one of the problems is hardware, but what you don't really see is also the operational cost, which is why this slide is showing you that the typical total average cost for tracking is about $5.3 million, and this is for a mission that could be a couple of years, like 3 or 4 years. It depends because they're all different, right? So typically the most important and the most cost intensive is when your satellite is traveling all the way to the moon, because you need constant tracking 24/7, and that's where most of the money is burned. Great. So did you want?
Sure. Okay. So we tried to estimate what is the cost of development and putting in orbit these 4 satellites, 4 minimum satellites, and we based the cost of the satellite from, we know very well the cost of making the 6U that we're trying to put in lunar orbit. So that's our starting point for the actual hardware cost. Everything else is estimated, like to the initial tech demo, like which is like building the instrument itself, is 500,000. So it comes up to like something on the order like 10 to 14 million dollars to do the final mission.
I can talk about this. So ITU is the International Telecom Union, and one of the biggest obstacles is that we would like to have seamless navigation all the way from Earth to the moon, right? This way you have to just pay one time for this hardware, and you have to pay any other extra hardware that only works in space, right? This way you can allow the manufacturers who make the GPS receiver do what they do best, and you can just focus on offering the service, right? So in order to do that, you have to broadcast these different frequencies. So this is all radio based. So GPS signals are L1, L2, L5, right? There are some different brackets within that, and then the U.S. military has access to their own, which also provides better positioning. You can assume for like missiles and whatnot, right? So we would like to then propose at a certain point, and then propose to have access to demonstrate this tech demo from EML1. So, right. What would matter is that we would have to propose and then to achieve funding so we can determine what kind of quality of service we will have, what hardware needs to be made, what's currently available. The clock's like the most important thing, right? Everyone's wondering, how do you keep track, right? So one important thing about GPS is having these atomic clocks. So you use cesium and some other standard, right? These are also now available off the shelf, very small scale, which wasn't available 10 or 15 years ago. So we know that that's just one major component, and obviously the proof of concept. So the proof of concept comes in, I think, next in this next slide, right?
Right, so I just want to talk about our development timeline. So we want to take advantage of the fact that we're doing this QPress challenge, and we're looking at having a little bit of extra in our volume and mass budgets. So what this means is like our current status is we've done a feasibility study, which is saying like, can you put up a small sat at lunar distance and actually like get what kind of accuracy can you get as far as navigation? So we've concluded yes, it's technically feasible, but a lot more work needs to be done. So we want to have this phase 1 of like to build the demonstrator like unit, which will fly on EM1 for free in 2018, which is estimated $2 million value.
Right. So can we clarify what EM1 is? So EM1 is the name of the rocket
First launch of the space launch system.
Right,
which will
SLS, so
eventually-
it's carrying Orion for a free return around the moon from that. Unmanned.
Yeah, unmanned. So for phase one, we're really like, we can fund this through NASA partnerships and government contracts. Because the funding level is low enough, but it would also be nice to get other funding. So then after our tech demo, then we need to build the full constellation, which is the large investment. And
There's something to that.
yeah.
Yeah, so we'll probably open this up now. See questions from the judges, any questions from the crowd. So thank you for having us. Happy to be here.
So my first question has to do with market share. Can you go back to the market share slide for a second?
Deep Space Network?
I'm curious as to,
No, the Deep Space Network. I think it's the following. Yeah.
Right, so which of these are your main competitors?
Deep Space Network is really like the only big competitors.
Yeah, I can tell you off the record that there have been a lot of plans for these CubeSats, and if you don't plan to use JPL's Deep Space Network, the person that ends up reviewing this project proposal, who is from JPL, will just throw it in the trash. Because, I mean, it's just, this is something that is considered from NASA as actually a contracted separate lab. So Caltech runs Deep Space Network because they run JPL. And this is the way that they generate profit. So actually our competitor would be JPL and Caltech.
Yeah, but I think it's important to note that, like, from NASA's standpoint, they don't care that DSN is NASA owned. They're like, oh, we have to pay our own guys. They care about total mission costs. So this is demonstrated, like, so Universal Space Network, which is a private, network of ground stations, and they manage a lot of communication satellites. But NASA actually paid them to manage LRO and GRAIL missions. So, like, if the cost is lower, NASA has no qualms about not using DSN.
So, how necessary, because you talk about the relative to the moon, like you're very dependent on noise representation, very dependent on having the moon as like the destination. But you also mentioned some abilities to scenarios
yes.
with Mars. So, what is the relation with that?
Okay.
You want to answer this one actually. Okay, so everyone thinks that why are we going to the moon, but actually you have to go to the moon to take that free flyby and get that gravitational boost in speed, and then you can head towards Mars or wherever you want. So that's why the moon is a high ground, because you have to pass it. And it would be silly not to pass it because you can increase your velocity passing it. So on your way over, then you can take advantage of not having to pay the ascent and being tracked continuously. That is the whole benefit.
The other thing is, so the constellation relies on this stable L1 around
orbit, right?
Very stable.
Which has been proven to work. There's a previous mission called Artemis that is actually still working and has basically demonstrated that you can then go to the moon, orbit the moon, do a low energy transfer to EML1, which is the Earth Moon branch point 1, or to the second one, right? And you can go back and forth and hang out as much as you want.
So switching gears here a little bit, so you're asking for 12.6 million. How's that broken down over the timeline of 2015 to 2021? So 6 years.
Yeah, so that's after 2018.
Okay, so up until between now and 2018, what's happening with you guys?
That's the 500K tech demo.
Okay.
Right. So we didn't cover it in like very detail, but pretty much we're going to do this CubeClutch challenge, right? So we're going to build another 6 CubeSats to go to the moon, right? And hopefully try to basically communicate from the moon, which we're working with AMSAT. So if anyone's from AMSAT, you guys will be able to actually capture packets. You need a 1 meter dish, and it looks like it'll be, it's going to be S-band up and X-band up and down. So you should be able to capture it, so that's nice. And the great thing is that we're still in the talks about it, but because of MSAT being so very helpful, at the end we're looking to basically hand off the satellite, right? And allow access to MSAT members. So while we are doing our own tech demo from EML1, we're going to allow access for MSAT members to then send packets and bounce off like voice messages and communicate with each other, right?
Yeah,
So that's what's happening.
Taking advantage of this flight is not critical to the business, but it's
a
a
free
clear
ride.
cost saving.
Right. The ride is worth like $1.5 million, $2 million.
What's the monetization here? What you're selling access to the network, selling to the access to the.
Right. So the service is what we're offering. So it would be easy for us to just turn around and say, yes, we'll basically take this CubeSat, gut it, and sell all these parts, right? Which is just a game of hardware. Now you're trying to sell hardware. Now you're competing against margins against these other companies, right? And then in this game is actually what ends up slowing this whole like commercialization of space. If you make a part that's brand new, right? If it's affordable, people will buy it. If it's not, then you pick the price, right? If it just costs too much money, NASA will step in or someone will step in and make the same thing cheaper or not better or both. So that game is a game that we don't want to play. But we can do something like that, and that is like one of our fallback options. But we feel that if we can reach this point, EML1, and then we can send these signals from that point towards Earth and demonstrate that we can do positioning, then using that, we are the first to market for the service. And that has never been done before. And with that, then we have enough, I guess, confidence to come around in the future and make this fleet.
What kind of cost savings would you be providing?
So we're at the point now that it's hard to basically it's hard to quantify it, how much people were paid, right?
Yeah.
Well,
So
the thing
they're
is,
currently paying DSN millions of dollars.
Right.
So
that's
I
for
don't
1
know
year
what that
mission.
means for us exactly, but it's not constant.
So the thing is if we can meet the same performance as the NewSpace network, then we can charge either the same or we can like just end up varying as different rates for the academic community, government, and then the commercial, right?
You need to have a little bit more of a solid answer for that.
Yeah, so that's new.
The way that I would focus on answering that, just to go off that, is what does it cost the NewSpace network right now to run the NewSpace network?
Right.
What's their overhead, what are their margins, what are your margins?
Right.
What is it gonna cost to get you set up, and then ongoing, what is it gonna cost to maintain the system, and then provide the same level of service that you're sending clients?
Right.
I would like to figure out what some of the margins.
Yeah,
That
so
was the
that-
question.
that's definitely true. As you can see, we have more work to do in that whole area. So that sounds really good. Thanks.
Just to help me better understand, you specifically describe the difference between DSN's network and the network that you're proposing, and the subsequent like deliverable, like you're delivering service for Earth doing missions and beyond potentially.
Right.
So like, I'm like working on a mission. Like, what kind of service would I get by signing?
You mentioned the payload, you think.
Right. So
that doesn't dramatically. So when you use DSN, what happens is that it's sort of overbooked, and so you have to schedule in advance. Like you're going to get like 3 hours every other day to track our satellite, and DSN has to like rotate and have the correct like ground equipment for your frequency during that time. So you get non-continuous service. But however, like if you're going to Mars, it really is like the only dishes that can pick up your signal. So you have to pay for it. But now consider the case where you are going to Mars, but you're passing through cislunar space because you have to. Why would you pay DSN? Like, so you want to have continuous coverage, right? So you put the bill, like the more you want to schedule, they increase the bill actually. It's it can vary from like $2,000 to $4,000 per hour of usage. So you want continuous usage for the first like 5 days of your mission. That ends up being a huge bill. What if you could cut, like you still have to use DSN when you pass the moon, but what if you could significantly cut the cost, like during that first, those first few days of your mission, simply by flying another device, which is self-contained.
I guess a better example would be like if you understand that the current GPS constellation is above LEO, and that these automated cargo launches that go straight to the ISS, they basically dock on their own, right? If you picture that all the way to Sisters, all the way to the moon, that's what you can do with it, and not more.
So your CubeSats orbiting.
So right now, there's nothing orbiting.
I mean, it's going to.
So this tech demo will be with the CubeSat, but it doesn't actually constrain us to using a CubeSat. We can go with a larger system like a small sat, and just so we can get a service life that would be reasonable for like 10 years or something, right? Because, you know, although CubeSats, they are becoming better and better and more popular, more like yes,
Capable.
You can't expect them to like provide consistent service for that long. Because the only difference from there and here is that there's a lot of radiation. So that tends to damage the components.
How many winners are there for the CubeSat?
Actually,
There's 3 winners of the ride.
So you win the ride and then you compete in space. So there, it's broken into multi-phases, right? But when you're in space, like you can actually share some of the prize too.
It's kind of weird that like
3. I think they might have a couple more slots. I think max 5.
there's, the way it works is like if you win the slot, probably you're going to get a big chunk of the prize money since there's only 3.
Can you say one more time how much the price money is?
Total is 5 million, but it's broken up and stuff. So we're looking like if you do the basic mission of entering lunar orbit and communicating, and so you enter lunar orbit early, you transit the most packets. That's like 1.6 million is the most you can capture from that 5 million.
Right. So it's broken up into 3 different sections. You can either just end up skipping the moon and do this deep space communication challenge, which was what AMSAT was thinking of doing. But so when we communicated, we got together. It works out better in this case to work together, and AMSAT will help us do the whole communications part from the moon. So that's so then the other part is basically orbiting the moon and trying to communicate from the moon. So those are the 2 that we're actually going for.
So AMSAT will be providing more of the software, or what are they
Hardware.
Hardware for the radio,
And then ground stations.
basically ground support equipment, which is like the ground station, the software needed to interface the radio packets, like what you get from the radio, to a server, and then distribute, and then you command and data handling, right? And then obviously access to their spectrum. So AMSAT has access to their own spectrum, and that's only for non-profit use, which is neat.
Okay, so cislunar space, satellites in cislunar space. There's none right now, as you just pointed out. When?
Wait, there are some. Like MMS is right there. There's 4 of them. Like
MMS is not, MMS is NASA, right?
But our point is that NASA.
I'm finished my
Sure.
question.
Sorry.
Right?
It's very exciting.
When do you expect, okay, so, let's grant there's a few. When do you expect satellites to be launching into cislunar space? In other words, when do you expect your first sail?
Steve. So right now it's kind of early to see whether these landers and these rovers on the moon will then follow some kind of standardization, and then there will be some like suppliers that come up so that market can grow. But in terms of CubeSats, it's only one more step. I mean, they can carry whatever kind of thruster to make it to the moon, right? And they'll try to then communicate with your CubeSat with their academic antenna, right?
Who is doing that right now? Or who is planning for that right now?
No one is going to the moon from an academic point of view.
Right,
There's
so,
no college.
I mean,
But this is.
But after this challenge,
This is why I think
parts
the
of
challenge
improvement.
is really a good investment by NASA because it's going to change the Cube satellite universe greatly. Because what does it actually provide? What it actually has provided is propulsion systems and communication systems that will work from lunar distances, which don't currently exist. But 3 years from now, they will exist and be available for CubeSats. And so what does that mean? You can enter higher Earth orbit and transfer to something else with a CubeSat.
Right.
Currently, you cannot do that. Really.
So you can hop on a ride for any comms, like any like communication satellite to GEO, they take a CubeSat, fire thrusters, and just get the oomph to go to the moon, and then you go there and do your mission, and then you crash. Hopefully, you don't damage any of these like heritage sites, and you can laser your name into the moon. and
Well,
whatnot.
maybe they're not gonna go to the moon, but they are gonna go beyond 20,000 kilometers, which is important.
But that's your value proposition. I mean, you're saying you're gonna put this on satellites that are gonna go to the moon. And what's going to the moon? What's what is planning to go to the moon? I mean, if you ask Buzz Aldrin, he says, the hell with the moon, we're going to Mars.
So
Yeah.
we tried to make this point in two different ways. One is that our service is not just for the moon, but it's for anyone who passes through system
And
space.
you have to pass through, pass through the moon.
And secondly, like, the moon is not as ignored as a lot of people think it is. Like, both, like, NASA, and China and India have all sent stuff to the moon in the last 5 years.
Let's
So-
let's isolate the moon scenario for now. Let's focus on Mars. What is the marginal benefit of using an Earth-based tracking system to get to Mars versus using something that you're going to build?
There, you can bring down your costs up until the moon,
Yeah.
and then you sign on again and use NewSpace Network.
So what is the difference in cost, and what is that difference in cost
Right.
multiplied?
Right, so right now we don't have an exact rate as to how much we should charge, but like you said, we should go back and do our homework and find
So,
out.
but that's totally fine. Like,
Right.
I guess it's related to Kaki's argument is that it's hard for us to estimate number of users. And you need to know number of users to estimate how much can we charge per
Yeah.
user in order to recoup our costs.
No, I get it. That's totally fine.
But that's
Yeah.
one way to do it.
Yeah.
Another way to do it is to say, this is how much they pay DSN right now, which we know. And we can say, we'll charge 2/3 of that per mission. Like,
Well, what causes the difference in cost? Is it is it
so-
adjustments to?
no, so DSN has to charge what it charges because like they actually operate just barely above their costs. So they charge like the minimum what they can charge. Whereas us, it's like we have a fixed cost of mission and operations. But then like with that one mission, we can service like not one user at a time, or actually DSN does like 10 users at a time because they have 3 telescopes. But it's like not one user at a time, but we can service. There's no limit really. It works like GPS.
So
Right?
one thing I want to mention, it's not apples to apples. See, DSN offers 2 ways. Basically, it's a 2-way system. You send a signal and then you wait for it to come back, right? That's how they range. And then you know where you are in space.
Dominant ship.
GPS is a 1-way thing. You don't have to communicate with the GPS at all. So you're always capturing these packets. So if you have the correct key, according to this model that you would pay, then you would have access to this and you can be tracked all the time. DSN, you have to schedule yourself. So you pay hourly, and this is something you have to pay monthly or annually. It's a different model.
Okay, as I see this, you've got 2 major obstacles. One is the regulatory, the authorization that you need,
Right.
which is huge. The other one is deep space network, because it is a monopoly. Where do you guys think that NASA wants no cost? Because in my experience, in writing proposals to NASA for the last 10 years, NASA could care less that the cost is lower. And if they have DSN in here, and what I heard you say is that anybody who has this need has to, and they write a proposal, has to go through DSN. If they don't have that in their budget, it gets tossed out. So how are you going to maneuver over DSN?
You mean pierce into this market, pretty much?
And really, I think
Yeah, I mean, how are you going to bust up DSN?
Well, I can tell you that personally, from people that I have worked with, right, they would love to use another service that doesn't cost as much as using DSN. And because you have to schedule it, let's say you have a flight you want to do next year, and you want to schedule all these hours for next year, and if they're all booked, you can't do it. You're done.
But DSN is a government construct, and you're talking about government people
I think
working through this.
in order
So
to
it's-
convince-
Government people
yeah.
can't even book their own time for DSN because it's so overbooked. that there's too much demand and not enough supply, right? So I easily know that my old boss, he would love to use this.
Can you use it? Can you
From,
use-
like, permission-wise?
Can you use your service?
In fact, yes, he can,
So-
and also he can use any other amateur or private network he wants. So I know that for sure. And
So,
it's like
yeah,
a little
the-
brush
what it is
between,
Because
like,
that was not
Take
clear,
it.
because when, like I said, you all went into.
It's all about risk management. So NASA is very risk averse. And so what,
well, it
so
really depends on
what, like the
because,
timeline that you will actually see is that like, so we have our own tech demo. And before NASA commits to using our satellites, they're going to fly the receiver with as a non-critical part of the mission.
right,
After they've done that enough and satisfied themselves that it's okay, then there's no qualms. Like if the cost is lower, then that's the impression I got after talking with satellite scientists at Goddard Space Flight Center. Like, because I guess I don't know.
Yeah, I mean, the scientists will say that, but the administrators won't.
in fact, let me tell you something, there's a thing called the Rapid Satellite Deployment Office. And this is an office that if you have a mission and you want to do this proof of concept, you quickly go through this catalog of satellites that have flown before, and you pick one. It has enough room for your, for your science instrument. You slap it on, you prepare for the launch, and you take the ascent, and you're good to go, right? So the interesting thing about that is that now you're seeing smaller and smaller satellites, and not just have CubeSats go like around Earth, not just the moon, but actually like deep space. I'm so hungry. I only had breakfast today.
Well, we'll get you off. And so I was just going to make a couple more points here. It's really hard. What I found hard here was understanding who your market is.
Right.
That's not good, because in my mind, it's not government, it's not NASA. Because DSN has that monopoly in a sense, government and NASA are obliged to use DSN because it is a government entity. Right, that's the one thing. I mean, I see your market as in you guys should focus on the academic, education, the educators, and the private companies. I mean, those are the ones, basically the people who find using DSN just completely out of their scope because it's so expensive. Right. The other thing is that I had a problem understanding your differentiation. What makes you different from DSN? Is it the price? That was not clear to me. Is it the production? Is it the quality? I mean, in one sense, you basically said what you're providing is same for same, just different somehow. I didn't get that difference.
So I can explain it if you want to hear it. It's
Well, then briefly, when you touched on the fact that you can simultaneously the one way versus two way, that was a differentiation.
Right.
So that's what it didn't come out in the pitch.
Right, that's true.
And my points are from you.
Yeah,
to work
that's
on
a good
your
point.
pitch and
So we'll bring that up.
focus on
I
that.
think we should have a slide to show like how currently DSN works and then how ours will work. And then we can talk about like the academic community and the private company thing as well.
So I'd also take a couple of remarks. Sure. I was the same for as tracking. You guys are doing something new. It's really cool. And not only is it new, but it's going to be a service like 5 years in the future. All right, not essentially, maybe more. Probably more than 5 years. Right?
These things take that much time.
It takes a lot of time. So you have to be very clear about what the uncertainties are over that scope of time, right? And make very clear assumptions about what the market's going to be like at that time. So there's obviously a certain amount of calculus that goes into those assumptions. And then really focusing on what that differentiator is between you and the current status quo if you're doing those missions. You did address those with some of my questions, like it's your continuity of service.
Right.
And there seems to be a big scheduling issue with NewSpace Network.
Right.
And I also would like to hear more about the value proposition, not just going to the moon, but also going beyond the moon. It seems like this first leg of the mission is going to be using that extra boost. So does it really give you that much value add on that first leg of the mission to be using your service over the ground-based system or the NewSpace network? Really clarify what that value proposition is. Maybe it's a very critical part of the mission. It's the beginning of the mission.
We have those costs.
Yeah, like what's my budget like if I'm on one of those missions? So it's ultimately, it's like the gentleman pointing out before. it's always a game of dollars, right? We're in the private space industry, so we have to be very clear about both the monetary aspects and the risks involved. Right?
Okay, thanks. Good job, guys.
Good job.
Thank you. We've got some questions. Yeah. You're not done yet. All right, let's move on.
No, it's okay.
If I understand correctly, after this first one goes up, theoretically, you can add more to your network.
No, it's just a proof of concept. So what would happen
Wait,
is
what do you mean by first one? You mean the
The
tech
tech
demo?
demo.
Or you mean the first four?
First four.
Yes, after the first four, definitely you can add more.
Right.
So essentially, you create the Internet of Space.
no, it's not really
internet, because it doesn't
It's
translate.
one
data.
way.
It's one way. Okay.
And so basically what GPS does is it tells you where it is and the time. So you keep tracking those packets, that information, and it's like having a light flash and it's like a lighthouse. So that's how you can do triangulation and know where you are.
Okay.
So those four cannot, so those are not meant to do internet. What would be great as like a backup though is to do comm relay.
Yeah.
So let's say that stuff is on the surface of the moon or orbit the moon can then relay it to us and we can relay back to Earth. And that's a game that's just like internet. You just charge gigabytes, like $1 per gigabytes, right?
Yeah, and it's not hardware game, it's a software.
Yeah, sorry.
If you say it's one way and you're going to put 4 satellites at L1, there isn't enough separation
Yeah,
for
that
the
was your decision.
triangulation.
Yeah, that was an interesting, so good thing you asked that
Part of
question.
our feasibility.
That is somewhat technical. If you want, I'll talk about it. Ready? All right. So there are different types of orbits, right? There's a small halo, a large halo, Lissajous, and then there's like a quasi-Lissajous. So you can decide what you want. So small or large halos are circular, right? The Lissajous is like a figure 8. So what happens is that you keep tracking it from Earth, and you have an idea of like the ephemeris, and like this is like the code name as to where it is in space.
Okay, but
If
now
you can track it.
all of these are L1.
Yeah, so it's not the
Well,
sun.
they're not at
it's the Earth
L1,
moon.
they're far from L1 going in a circle around.
So everyone thought that
So
at
part
L1.
of, part of the feasibility study is saying, how big does the circle have to be to match whatever accuracy you want?
So for everyone wondering what is L1, like the most basic way of saying it is like where the gravity of the Earth cancels with the gravity of the moon, right? So it's a point that used to be considered an unstable point if you're in the same plane as the sun, Earth, and moon, right? You're orbiting. That is like an unstable case. If you have a halo orbit, that is a perpendicular orbit to this plane, then you're okay. So that's what's been proven with Artemis. And yes.
Okay, so but from L1, you're only going to get one more data point that you run. And I still don't understand
Oh,
what
I can
what
explain.
we have to use.
No,
this.
So from Earth to the moon, you have a straight line, right? It's that this halo orbit is like a ring around the line. It's just along its axis, right?
No, I know where L1
Yeah,
is.
yeah. So you were asking if they are too close together, how are you going to get anything useful? And that's the study that we have to do to find out. Small halo, large halo, Lissajous, quasi-Lissajous, right?
And the other thing is, I don't know why you necessarily have to use the side lobes, because we've already shown that satellites in GEO can pick up the main lobes.
Right. There's the thing. There's a name. The fringe. It's off of the atmosphere, and then you have ionosphere and troposphere problems, because they tend to delay your signal. But we didn't show the main lobe because that's obvious. I mean, that's how everything works here, right? The side lobes are just coming from the nature of having an RF antenna. So that's currently how you capture these weak packets, these weak signals, right?
Why wouldn't you just count on the main lobes?
Yeah. So actually,
Most of the power is blocked.
there's a loss factor from those two. So you have to go through those different layers of the atmosphere. That loss factor gives you worse positioning.
Then the side lobes?
I'm not sure about that because it depends what the power is for the side lobes. So right now, GPS has a minimum power requirement for the main lobes, but not for the side lobes. They just do whatever they want. So if they have some law come into effect and say you need this much power and you have to have this much gain, then you can have like a consistent service. But even that service is going to be like having like some kind of spike we have, like just like spotty. So you may not have line of sight with 4 GPS satellites, you may just have 1. That's when we come in and we can provide the service.
One last, so you are going to need some ground command and control aspect. I'm not suggesting you use DSN. You talk about S and X band, but you have to talk to your satellites, you have to do care and health. You have to know their position so they can accurately be part of the GPS constellation.
Right.
And, clocks aren't that cheap. And,
They are, actually now they are.
and
There are these chip scale atomic clocks, cesium and rubidium. They're like less than $2,000 each.
so,
So you carry 2
what's
sets of
your
each.
vision for your ground command and control network?
So that's a point that in the future we'd like to negotiate with the Air Force to see if what can we do having like a separate ground support, just like a separate control system from the ground, or having something in unison with them. Because they're the ones that carry all these clocks, all these list rated clocks, right? So that's something in the future that's coming up.
I think there's a lot of options
That's
for ground.
further down the line though. And worst case
Maybe we
scenario,
have to build our own.
ITU says no, then we'll have to basically purchase our own frequencies. And we can broadcast those, which is a joke. That's like so much money.
Yeah.
And especially since you want the lower wavelength ones, the lower frequency, larger wavelength ones, which is like where all a lot of this, this stuff is used. Because like the higher frequency, right, tends to have higher free space loss. So that we wouldn't be able to project these.
Now, I'm
Sorry, you guys are super technical. You guys, sorry about that. Yeah.
Aren't you gonna have to buy your own spectrum anyway, because the spectrum that you're gonna use with the CubeSat channel is for not-for-profit. So if you wanna monetize it, you're gonna have to buy your own.
Right, but we're not going to monetize this now. So the first one will be carrying a radio transmitter to transmit these packets in accordance with the authorization we would hopefully get from ITU to use their frequencies. So then we can transmit at least L1. This is like the coarse pointing. We can transmit that down. Proof of concept's done. No money has been generated. Concept has been completed. Mission successful, right? And the next stage is the flock, right?
Which will include that spectrum.
Right, so we don't have to purchase this band of frequencies from ITU. We can have access to this. I'm sure that there's some monetization. I'm sure that they would want some money. We need like PRN codes. Maybe there are codes that we can reuse again.
Was that figured into that? Was it 12 million? That's the second part?
No, it doesn't cover it because you really haven't yet found out how we can move it this way. Right? But that's part of the whole dealing with ITU.
And there was a reliability issue you mentioned a couple of times?
Yeah, CubeSats, they're going to be in this environment that's not shielded by the Earth. They have this radiation environment, and there is TID, which is total ionization dose. You do shielding, and the last couple of years, yeah, it's great. And you have single event from the sun, which can literally burn a hole through your flight computer, and then that's it, game over. So what you're seeing from this challenge is a new set of hardware that can be sold, and everyone can just buy it and go to the moon with your CubeSats, which is nice. But we don't want to play that game. So the service question that you're having, yes, one that we have to address that we may not be able to do with CubeSats, but probably with a set of small sats.
So yeah, the question is so why do CubeSats right now fail to do radiation so much time? It's simply because they're not prepared for it or designed correctly, not because of some technological reason.
I'm sorry, say that again, please.
So like, a lot of CubeSats actually fail due to radiation.
Sure.
And the reason for that, there's no like fundamental technical reason why they do that. Like, it's not that it's impossible to make a CubeSat like radiation resistant. It's just that they do not include that in their design because they have like a 1-year life in low Earth orbit, which has low radiation requirements. But actually, funny is like, I was just reading in the news like that the giant solar sail that's like from Planetary Society and like Bill Nye's like public face now. And they had the whole thing like they went up for 6 days, they had no contact because, and they said the reason was because they had this like radiation upset their flight computer, and then it rebooted itself and came back. This is very common for CubeSat satellites. We've heard this from all different corporations who fly CubeSats. They say it's so common. Even some people told us like they just automatically reset the flight computer every few hours. So, but yeah,
It can be fixed.
it can be fixed.
It's
Yes.
just costly. You have to buy parts from the NASA's.
Yeah.
Yeah, there
You have
is.
to have very careful design and you have to have metal shielding.
Radar, single net.
Yeah.
Now,
Okay,
I don't-
I think we need to stop this unless there's one more question.
You guys can just find us after, we can talk.
Yeah, we discussed with the bank, but.
Sure.
Before we even run out of start it.
No, my phone is waiting right here.
Yeah.
It's waiting, it's looking at me.
Excellent, thank you both.
Hey, thank you. We can have an intermission now. We're gonna get someone joining us from California. So we'll be streaming in onto the TV.
Watching from California.
Is that someone watching this one?
Yes, one person.
Radiation environment, you don't want to get them.